So today we're going to look at some triangle proofs that involve angle relationships. So let's just quickly review these 6 angle relationships we had earlier in the year. So linear pairs are two angles that are next to each other and make a straight line. So like these two right here that I've labeled. And notice how I labeled one of them with one arc and one with two, because linear pairs are supplementary. They're not always congruent. Vertical angles are formed by intersecting lines, and they're like the opposite angles at those intersecting lines. And these are always congruent, and we've seen these before in proofs. These pop up a lot. Alternate interior angles. As long as the lines are parallel, then the alternate interior angles are congruent to each other. And also, these pop up a lot in triangle congruence proofs as well. Alternate exterior angles, also congruent as long as the lines are parallel. So like that's this angle and this angle. These don't pop up that often. Same side interior angles don't pop up that often either, but as long as the lines are parallel, same side interior angles are supplementary. They add up to 180. And corresponding angles, as long as the lines are parallel, these are congruent. These don't pop up too often in triangle congruence proofs, but they do pop up in triangle similarity proofs a lot. So just save that for next unit, and then we'll talk about it more. Okay, so you might see this sort of diagram for a triangle congruence proof. And these diagrams are often called like a bow tie proof because it kind of looks like a bow tie. And the things that pop up a lot here are you're going to see a lot of vertical angles, which you should already see some now, and you're also going to see alternate interior angles. So let's take a look at where these things pop up. So the vertical angles right here are going to be right at the intersection. It's right here at point P. So like there's these, but we don't care about these, of course, because they're not really a part of the triangles we're looking at. We want these, so angle TPR and angle QPS. So like the vertical angles are always congruent right there. Now, the alternate interior angles, which I suppose I should have labeled these parallel lines with red, because the alternate interior angles are only congruent when the lines are parallel. And there's two sets that pop up here, actually. So if you look at angle R, that's congruent to angle S. And it's sometimes a little hard to see, but if you just think of it like this, you extend this line and extend this line and then extend this line right here, you can see that this is the transversal cutting through the two parallel lines like that. So basically it looks exactly like this if you extend the lines, and then we have this angle and this angle. And the other set of angles that are also alternate interior angles, when you look at this as the transversal, if you look at TQ as the transversal, then angle T is congruent to angle Q. So what we have right here, we already have that all three of these angles are congruent to each other, which makes these two triangles similar to each other. The only thing we need now to prove they're congruent is just proving that one side is congruent to another side. So like if a given statement said that PR is congruent to PS, boom, right there we already have these triangles congruent either by angle, side, angle, or by angle, angle, side.